Next, we're going to talk about solving trigonometric equations. So solving trigonometric equations graphically involves graphing the corresponding function and finding its zeros. Because we're looking for where does it equal 0. We get everything on one side and solve. These zeros represent the solutions to the equation within the specified domain. So if we have that the sine of x equals 1/2, we can rewrite that as sine of x minus 1/2 equals 0. And then we're just looking for the zeros, the places where it touches the x-axis. And so what we see is that's occurring at pi over 6, 5 pi over 6. And then we would repeat that for all of the other multiples of that as well. So if we want to solve number 2 graphically, let's just grab our graphing calculator here. So we'll go to y equals, clear out what's in there. Also make sure to check your mode. You want to make sure you're in radians to graph this. So we'll go to y equals and we will plot 5 times the cosine of x plus 1. We'll go to our graph and we're looking for the zeros, the x-intercepts. And so if we, and we're only looking for them between 0 and 2 pi. So that's why on number 1 it was just pi over 6 and 5 pi over 6 because I forgot to mention they restricted the domain here. We're just between 0. We can equal 0, can't even equal the 2 pi. So between there and there. I can see, 2 x-intercepts here on my graph. Remember, to find them, we can hit second calc and choose the 0 feature and then give it a left bound. So for this first x-intercept, that's a good left bound. There's a right bound. On your calculator, the physical calculators, you'll have to actually hit enter a third time for the guess. And you get that first value there. The first 0 is 1.772 if we round it 3 decimal places. Let's find the next one. So second, calculate, choose 0. So it's second trace to bring up the calculate menu. Then we're choosing option 2 for 0. And so for a left bound, here we go, and then go to the right of it. And again, on the actual calculator, you gotta hit enter one more time, and we get 4.511 if we round to 3 decimal places. All right, so let's try the next one. If we go to y equals, clear out what's in there, 2 sine of x, and then we've got to square that. Oops. I want it there. Squared plus, minus 5 times the sine of x plus 2. Okay, so again, we can see 2 x-intercepts there. We just have to find them. So second trace to bring up the calculate menu, choose option 2 for zeros. I'm gonna go find the one all the way to the left first. So I gotta move my cursor using my left and right arrows until it is to the left prior to that first x-intercept I'm looking for. And then move to the right of it, and then hit enter one more time if you're on the actual graphing calculator. So our first 0, we've got 0.524. And now let's find the other one. So second trace to bring up the calculate menu, choose option 2 for 0. So use those left and right arrows to move that cursor to the left of it, so just prior to it, and then to the right of it, and enter one more time on the actual calculator. So you've got 2.618 for the other solution there. All right, so we can also solve them using right triangles. And our special right triangles and what we know about the signs of trig functions depending upon which quadrant they're in and the quadrantal angle. So we remind you of all of that here. So here's your 45, 45, 90, your pi over 4, pi over 4, pi over 2. It's 1, 1, square root of 2. For your 30, 60, 90 right triangle, your pi over 6, pi over 3, pi over 2. Remember, it's 1, 2, square root of 3. So square root of 3 is your longer side, so it's across from the bigger angle, which is that 60-degree angle, which is pi thirds. 1 is the smaller side length, so it's across from the smaller angle, 30 degrees, pi over 6. Remember on your unit circle, so this point 1, 0 here means cosine is 1, sine is 0. at pi over 2, cosine is 0, sine is 1. At pi, cosine is -1, sine is 0. And down at 3 pi over 2, cosine is 0, sine is -1. We know in the first quadrant, everything's positive. Second quadrant, the sine and cosecant would be positive, everything else negative. Third quadrant, we've got tangent being positive and cotangent, but sine, cosine, cosecant, secant are all negative. And over here, cosine and secant are positive, everything else negative. So we're going to remember all of that from previous units. All right, so number 4, we're going to get the sine by itself and use the inverse sine then to solve for the angle measure. So I will add the 4 to the other side and then divide by 7. And so then to find theta, again, since this is not a special, it's not one we can evaluate with a special right triangle, we'll use that inverse sine feature. So remember, we're going to hit second sine to bring up the inverse sine of 4 divided by 7. And in terms of radians, we get 0.608. Reminder that sine would also be positive though, so it's positive in quadrant 1 and quadrant 2. So to find a reference angle in quadrant 2, remember it's always pi minus theta prime. So I've got to do pi minus the 0.608 to find my other value where we'd have that positive output for sine. So second, and the caret symbol is how we can get pi quickly, minus 0.608 gives us 2.534 for the other angle measure. So the two angles that would give us a sine of positive 4/7 are 0.608 radians and 2.534 radians. All right, number 5. So if we take a look, we see tangent of x in both of these terms, which means we can factor. So let's factor out a tangent of x, and that'll leave us with the square root of 2 times the cosine of x minus 1, still equal to 0. And then zero product property allows us to set each of those factors equal to 0. So the tangent of x equals 0, or the square root of 2 times the cosine of x minus 1 equals 0. So if we focus on solving this first equation, tangent of x equals 0. Well, in order to get 0 for the tangent, remember tangent is sine of x over cosine of x. So to get 0, we would need it to be a sine of 0 and a cosine of 1. So if we take a look here, or -1 would work for the cosine as well. So it's going to be here or here. If we take 0 divided by 1, we'll get 0. If we take 0 divided by -1, we also get 0. So that tells us the tangent of x equals 0 when x equals 0 or pi radians. All right, for our second equation, we'll add the 1 over. We'll divide by the square root of 2. So we're thinking about angles that provide a cosine of 1 over the square root of 2. So right away we know that's pi fourths. The other place cosine is going to be positive is down here in quadrant 4. And so to get our angle, we take 2 pi minus the reference angle. So 2 pi minus pi fourths gets us 7 pi over 4, because 2 pi would be 8 pi over 4. So 8 pi over 4 minus pi over 4 gets us 7 pi over 4. All right, so all the possible values for x: 0, pi over 4, pi, and 7 pi over 4. All of those angle measures would give us the desired output and would satisfy the equation. All right, so I see a quadratic. As soon as I see something squared plus linear plus constant, I'm ready to factor. Got to put all those quadratic skills to work. So 2 is prime, so it's got to be 2 times the sine of theta times the sine of theta, or sorry, sine of x times sine of x. 1 is also prime, so it's got to be, well, not prime, I'm sorry. 1 is officially not prime, but the only things that multiply to 1 are 1 and 1. So if you check our factoring, 2 times the sine of x times sine of x would be 2 sine squared of x. Outside, we're going to get 2 sine of x. Inside, we'll get 1 sine of x. So 2 of them plus 1 more gets us 3 sine of x, and 1 times 1 gives us 1. So now that it's factored, again, zero product property allows us to set each of those factors equal to 0 individually and give us 2 equations to solve. So for the first one, I'll subtract the 1 over, and then I'll divide by the 2. So I'm looking for angle measures that give me a sine of -1/2. All right, well, to get a sine of 1/2, opposite over adjacent for sine, that's pi6. But if we want sine to be negative, we've got to be down in quadrants 3 or 4. So again, pi6, but we need it down here and here. So pi plus pi6 will give us 7 pi over 6, and 2 pi minus pi6 would give us 11 pi over 6. All right, so for this one, we've got to subtract the 1 to the other side. So we're looking for when does sine equal -1. That's one of our quadrantal angles down here at 3 pi over 2. So x equals 7 pi over 6, 3 pi over 2, or 11 pi over 6. All right, number 7. So first thing we'll do is just divide by the 2. We don't need to factor here. We can solve this one with square roots since it's just a quadratic term equaling a constant. So we'll get that quadratic term by itself. And then to undo the squaring, we take the square root. Remember that anytime we take a square root, we've got to put down plus or minus. So the square root of 1 is 1, and then in the bottom we'll have the square root of 2. So if we want the cosine to be 1 over the square root of 2, that's pi4. And it could be positive or negative. So we need all possible angles in all the quadrants with a reference angle of pi4. So it'll be pi4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All of those would work because they'd each give us a cosine equivalent to 1 over the square root of 2. It's just positive or negative depending on which quadrant we're in. All right, some trickier ones. So number 8 here, I've got something squared, but it's a different trig function. So I'm going to rewrite this. I can rewrite cosine squared in terms of sine so that I've got the same trig ratio. So remember that cosine squared is equal to 1 minus the sine squared of theta if we use that Pythagorean identity. So then we can distribute on that right-hand side. And then I'm going to get everything on one side since it's quadratic, since we have the squared term, the linear term, and then the constants. So I'm going to move this over here and this over here so that leading coefficient's positive. I prefer that leading coefficient to always be positive if it can be. So positive 6 sine squared plus 7 sine theta. And then 3 minus 6 gives me -3 equals 0. So now we're going to factor. So 6, probably 3 and 2. So I'm going to try 3 sine of theta and 2 sine of theta. I know it's 3 and 1. I just got to think about where to put them, what I want them to multiply by. So to get 7, if I could get 9 minus 2, that would work. So if I put 3 here, so that I have 9 sine of theta. And then if I put -1 right here, I'll get -2 sine of theta. So 6 sine squared of theta, 9 sine of theta minus 2 sine of theta is 7 sine of theta, and then -3. So then zero product property, set each of those equal to 0. And then solve for the sine of theta. Okay, so the first one I got down to sine of theta equals 1/3. That's not one I can evaluate with a special right triangle. So we're going to use our calculator again here. And we're going to go inverse sine. So second sine to bring up the inverse sine of 1/3. So we're going to get 0.340, but sine is also positive over in that quadrant too, so I also have to do pi minus 0.340 to get my second one. So second caret to get the pi minus this gives us 2.802 as the other value. And then if sine of theta equals -3/2, well, that's impossible. We can, our sine and cosine values are always less than 1 because it's opposite side over the hypotenuse, and hypotenuse has to be the longer side, so it's impossible for it to be bigger than 1. So these are the only two values that would work for that equation. All right, so number 9 here. So this is sine of x. And then cosecant, remember, is 1 over the sine of x. So I'm going to take this entire equation and multiply through by sine of x to fraction bust, get rid of that fraction, and have everything in terms of sines. So I have sine squared x, sine of x times 1 divided by sine of x would just be 1, equals -2 times the sine of x. So I distributed this to every term of the entire equation. That's why I'm allowed to do it, because I'm just scaling up the entire equation. And now I'm going to get it all on one side since it's quadratic so that I can factor it. So I move that -2 sine of theta to the left and have sine squared of x plus 2 sine of x plus 1. And so I've got sine of x plus 1 times sine of x plus 1. Because sine times sine gives us sine squared. One of them plus another gives us 2 of them. 1 times 1 is 1. So you could also condense that and write it as sine of x plus 1. Quantity squared equals 0. But with zero product property, we just need to take 1 and solve it. So we'll subtract the 1 to the other side. So we're looking for where does sine of x equal -1? Well, that's down at 3 pi over 2. So that's the one and only x value that will work for that equation. All right, so when solving these trig equations, we've got to use a combination of our lots of algebra skills with your factoring of quadratics and such, and zero product property, lots of trig identity stuff, recognizing, oh, well, I could rewrite this and then multiply through. I could rewrite this. And then absolutely have to remember your special right triangles, quadrantal angles, and sines of trig functions.